Most people already know the basics. I looked up my YouTube page and I typed in Gaia Hypothesis, or just Gaia spelled Gaia, and I found that there doesn't exist a paper on it or any kind of thought concerning it. And I've been meaning to work on this for some time, and I finally got around to doing that. I don't know if anybody really asked for me to do this, but I thought it was worth the work. It's definitely worth discussing. The Gaia hypothesis proposes that life creates its own habitable environment. Now, Stephen Jay Gould and Richard Dawkins had a problem with this. Can't remember the guy's name that thought it up. I should have put that in here, but I didn't because I didn't want to name drop him, I guess. But anyways, the Gaia hypothesis proposes that life creates its own habitable environment. This hypothesis is not needed. It is the environment that creates the life. The stars evolve on huge time and chemical scales to create life itself. Life is a byproduct, a direct, intimate result of stellar evolution, which is planet formation. It does not drive the evolution of stars. Now, the Gaia hypothesis, what I think it means is that life itself creates its own environment, which on the face of it looks like it's, something really great, but there are huge problems with that because it's easy to read. Okay, I'll go ahead and continue reading this. The Gaia hypothesis states that life creates its own habitable environment, but this is not correct. It is understood that stars create life far into their evolution via the general theory. This means the environment existed before the life did as well. The life sprung up from the environment, creating it naturally. If you remove the environment, the pressures, temperatures, atmospheric composition, etc., you remove the life. If you remove the life, you still have the environment that is hospitable to it. And that's the big problem. The Gaia hypothesis states that the life self-regulates the environment to make sure the life can still be there. But it from an intellectual standpoint, it looks like a good idea, but then you have to remember, okay, let's take it to the extreme. Let's put an astronaut onto the moon without a spacesuit on. Is the astronaut going to make the moon habitable? No. No way. The astronaut is gonna die. Like within a few seconds, he's gonna stop breathing, and then he's gonna go brain dead because he was not gonna be able to get any oxygen in his brain. It's also a vacuum. I don't know. There's lots of other things that happen to your body under vacuum, but it's not pretty. So just taking life and putting it somewhere where the environment is not hospitable to it doesn't make the environment hospitable to it. And the biggest part, I'm guessing that's the problem that Richard Dawkins and Stephen Jay Gould had with it. I'm assuming that to be true. I didn't look into their arguments against it because I don't really care what their arguments are, to be honest. I only care about the arguments against it from a stellar metamorphosis standpoint, the idea that I understand, the theory I've been working on. And that means life does not drive the evolution of stars. It is a unique and complex byproduct of their evolution. So the Gaia hypothesis basically means that life is, or the star is basically alive too, and it's the life that sustains the star being alive, whatnot, but not in exact terms. And what I'm arguing is that the Gaia hypothesis, also taken to the extreme from stellar metamorphosis standpoint, is that life itself makes the star evolve so that life can exist. That doesn't make any sense. Let me state that again. Stellar metamorphosis means the star creates the life as it evolves from extremely complex, hostile, toxic environments that have extreme pressures and temperatures, and eventually that environment creates the life from all those chemical processes and different temperatures and pressures that change over the star's lifetime. as it evolves in huge amounts. So to say that life does not drive the evolution of stars is pretty obvious, because the star evolves on its own without life even needing to be there in the first place when it's very young. So to say that life drives the evolution of stars, that drives them to be habitable, no way. There's no way the Gaia hypothesis is correct. And that's basically it, you guys. I don't want to beat that into the ground, but I'll link this to the bottom. It's already up on Vixro. And I got an email. I think I got it yesterday, probably today, early in the morning. I can't remember. But the question was asteroid impacts versus Mercury and the Moon. Now, I have Mercury is between 7 to 32.75 trillion years old, and I had the Moon as, I think, at least 25 billion. Now, when I first started working on this theory, I want people to know that I didn't exactly know how old these objects were. So the age differences, the age progression, where I actually try to tie together the theory into the observations, is going to change a lot. So that being said, I don't know how exactly old the Moon is, but I have a very interesting reason why the Moon should have a lot of craters versus Mercury. And this is very interesting because it's the Moon. It's like right there. You can look at it every day, or almost every day. The Sun and Mercury, I have them up here. You have the incoming asteroids getting pulled by the Sun's huge gravitational field. Most of the asteroids just zoom right past Mercury. There's nothing really to hit. Mercury, it doesn't even. But as you get closer to the Sun, the density of the asteroids that the Sun can pull in increases significantly. So if there were any object to be near the Sun, it would obviously get hit with a lot more objects than versus when it's out here. And that's exactly what I'm saying happens, or it has happened. When Earth was a much larger, hotter, radiant star, it had captured the Moon a long time ago. And the Moon was obviously pre-existing around the Earth when it had captured it. So you have the Moon sitting really close to the Earth star. Where I say Earth star, I mean it's old star, but I mean, to people that are new to this theory, Earth was large like the Sun. And the heat of the Earth was melting one side of the Moon, causing huge amounts of what are called mare, which are basaltic lava lakes, which then had previously solidified. And the heat of the Earth was sitting here blasting one side of the Moon. And since the Moon was sitting really close to the Earth star, a lot of the asteroids didn't zoom past it. They were directed towards it. You see that? Towards it. But not towards it per se, but towards the huge gravitational field that the Earth had in the past. So naturally, these asteroids wouldn't have zoomed past it like in Mercury's case. They would have just went straight to it and kept on hitting one side of the Moon, because the Moon was tidally locked around the Earth when it was a much younger, hotter star. And that's why we have a huge asteroid field on the back side of the Moon, and we have lava lakes in the front side where it's facing the Earth. Of course, this isn't going to be accepted by the dogma, because to them the Earth formed as is, and there's nothing special about the Earth. It's just a giant rock which clumped together in outer space, absent mechanism, within 10 million years. It's like they live in the 18th and 19th centuries still. It's unfortunate though, because ideas like this get considered to be crankish or crackpottery or what have you. But I think that's what happened. The moon didn't form from a collision of some other body which then recoalesced around the Earth. That's why the Moon has such a much proportionally larger mass than most moons versus the gas giants and their smaller moons. Let me restate that. The Earth has just as much mass that it has, and then the Moon has a much larger mass in proportion to the Earth versus like Ganymede, and Jupiter. So Ganymede's really tiny and Jupiter's huge. But the Earth as it is now versus the Moon as it is now, it wasn't always like this. The Earth had an extremely massive massive. And that mass made a lot of the orbital dynamics that we see inside of our solar system basically non-existent. And the Moon was the very tiny little thing that had been captured in Earth's early history, which is why also if we were to radiometrically date the surface of the Moon, a lot of the isotopic abundance are going to match the Earth because the Earth was irradiating the Moon with its own material, and it was going inside the basaltic lava lakes. So it was absorbing all that irradiation, making even surface measurements probably maybe even like 50 to 100 feet deep, if not more, as the isotopic abundances that we can measure on the Earth. That's why the Moon's going to match a lot of those. That's why a lot of the Moon rocks supposedly match it. But the Moon had been there long before the Earth ever even was a young hot star. So, okay, I guess that sums up this talk. Hopefully this helps people look at the world differently. I don't know. I'm pretty tired right now. I think I'm gonna go to bed. But anyways, take it easy, guys.